How do I know it's time to wrap up a project and start a new one when I actually dread starting a project? I love the Pagan project, but I just want it to be done. I want this library to be done. I don't want to have to revisit it all the time. I got other stuff to do, and the work that I have to do today is going to be very boring unless you're just coming to Pagan for the first time and you don't know what it's about, or you're just coming to software development and Go for the first time. In which case, this is probably your stream because I'm going to be talking through everything I did to build up this library from the beginning. And yeah, so we're going to go about it that way. And we still have to implement the lookups for the first class functions. How's it going, Carlos? So that is all coming. So yeah, how's it going, regex generator? Carlos, I'm pausing because I was just reminded of sort of a core thing that's going to be involved with the error codes that I really want to test before I run further forward on a particular style for this, and that's related to. Wait, this isn't right. What's going on here? Why do I have a VI directory? Something is not right. Something's really not right. Oh, never mind. Okay. That's me slowly building it back up. Oh God, I panicked for a second. I forgot about I had my old one here. So that's what's going on with that. Yeah, I was really scared. So we have this notion of chuck functions, and we talked a long time ago about how they don't print well in error messages because they're a first class function and not some string or token. So when something doesn't match and you want to say, well, what were you trying to do when it didn't match? There's nothing to print because it's just a function signature. So I'm 99% confident that I can build a symbol table, sort of a map, and put the reference to the individual functions in there, and then when that isn't looked up, when it's encountered in the type switch, that I can pull in the actual text name of it as an error message. So kind of like you have long names for integers and for the tokens and stuff, you can do the same thing for a first class function. But I haven't tested that. There's no reason for that not to work. I've never done it, but I absolutely am confident that it will work. But I should probably do a test of that before I build the rest of this revised refactored architecture for Go for Pagan, based on that assumption. So I'm going to do a little bit of a test. Sometimes this kind of thing is just much easier to just write your own tests, and I think it's a better autodidactic way. I think the people who were inventing electricity in the old days, they didn't go try to read a book, or unless they were stealing somebody else's idea, I guess, because it was kind of a war to see who could win. But the idea of just trying stuff out and seeing what it is, seeing how it behaves. That's how I figured out that even if you have a different alias, if you have a different import prefix for package namespaces, they are all pointing to the same underlying symbol table. So you cannot use package globals, for any kind of encapsulation, variable encapsulation or otherwise. And that informed a decision I did recently to use this sort of agent or whatever entity to put everything else in so that they're all in the same namespace. All right, so next, let me see what I got going here. So I actually need to do this little test here. I'm going to make a directory I'm going to call first class func test. Actually, just first class func. So what I'm going to do here, if we eventually get a job. Hi, Jan. You're talking about Go programming. My biggest recommendation is to keep programming and keep trying, making stuff, participating on projects, reading through the entire specification for Go. If you want to learn Go, this is what I recommend. Write a lot of Go and read through and work through the books that are on this list. So, and these are not books. These are all free. They're all online. You're going to have to read a lot. If you don't want to read, then maybe you don't want to be a programmer. This is actually the specification for the Go language. And you're like, well, that's really high level learning. Well, you know, that's how you start. So there are other books and stuff down here, and I've listed a bunch down here. There's none that I particularly like more than this. So anyway, all right, back to what we're doing. So I need to make, the way I'm going to do this, so let's say, for example, let's make a directory in here that's a separate package, actually. And we're going to say FCs for functions, okay? FNC, how about that? No. FCN, no. FCF. I can't make, it's just a test, but I am so stuck on the names. So let's make a function in here. Happy little function, right? People keep calling me Bob Ross, but so we have an FCF.go. This is, it automatically does main. We're not going to do that. So FCF. Fuck, I'm not going to be able to type that. How about just F? Funks. How about that? How about that? What do you think of that? So anyway, then we do this. So define a function. It's like some function, doesn't matter. And say it takes a string or something. String and returns a Boolean. And I'll give it a type. So type some, type, we'll call it an is function. An is function. An is function is some func that takes an S and returns a Boolean. Okay. So if you don't know about functions, maybe you know about that. So this defines the type for a function, and this fulfills the type for the function. Function is a little bit different, of course, than other data types, things like that. Return false. So let's say this. I mean, if S equals some return true. I mean, it's just some stupid thing. All right. So what? Well, now what? So I actually want to use that function, and how do I do that? All right. So, well, here's the problem. So let's say I wanted to have, I don't know, any textual information associated with the function. So I'm actually going to put it all in the same file, but normally this would be in a different file. So I'm going to say, I'm going to make a map here. I'm going to say, and this is all, pretend this is all generated automatically. So I have a map, let's see, var, we'll say long names or something. Names, how about that? So, var is a map of isfuncs. Actually, it's a map of, I guess we're going to say interface here, because you can make anything a key. And I'm not sure because I think, well, we're going to find out. So we'll just put interface for now. We don't care. So map interface and then string. You get this big, long, happy thing. So, and then what? We're going to say, so the sum, that's a reference to the sum You see how it's a sum and it's coming from here? That makes it an identifier. If I did sum, it would be a string, and we're not doing that. So we do sum, and I'm say sum longer name. All right, and that says this is where it gets kind of weird. And if you're a beginner, you're like, what? But this is using the symbol for the function, the underlying, memory address, as the key to look up some data that you want to associate with that thing. Now I could put usage information, I could do whatever. So if I have a situation where I want to document a bunch of, like, let's say I have an entire suite or library of functions that I want to be able to use as first class functions and some sort of pseudo syntax, which is what I'm doing. And I want to be able to pass that library around, but I want, in the user space, I want them to be able to communicate something about those functions that is not contained, just can't look it up in the language. And also, reflection, this is a form of reflection, but it's not real reflection. Reflection would be looking at the thing itself to see its name, in which case the name would be is.sum. No, it wouldn't be. It would be funcs.sum. And we don't want that. So what I want is I want to actually have, as the most, here's another reason to do this. Okay. So let's say I want to associate a kanji name or something like that for this identifier. And I want people to be able to use, kanji words, and then maybe the parser would parse those kanji words from a text string, and then it would associate this function to go with it. It's a reverse lookup of this, but we'll just keep the, if you want to be able to read it, right? So this is important, and frankly, it's going to be hard for beginners to get their head around this if they don't understand what a first class function is. So a first class function is a function that's passed to a higher order function that's just like anything else. And all those big fancy words mean are, you can use a function, the name of a function, just like any other variable. And that's what I did here, right? Sum is a variable that contains the underlying pointer to this function. So it's just a variable. So function names at the end of the day are just variables. And that's why anonymous functions are easier to get your head around on this, because you're just assigning to, what would otherwise sort of look like a string assignment. You're just assigning a variable, an anonymous function, and the function goes in there. Same exact thing. Almost the same exact thing. It's like nearly the same exact thing. So far my test is going well. The final output of this test is going to be to actually look something up by its name. All right, so let's do that. So let's do, I don't know, let's do, I guess, it may not go, and let's import this. So let's say, I don't care about the import, so I'm going to go ahead and just do it here. This will clean up. Let's go ahead and import what is it, funcs. Oh, see, I didn't use anything, so I cleaned it all up. Dumb me. So let's do this. Let's say fmd printf println, and let's look up a function. So let's say I want funcs dot sum. Now you're gonna, well, let's do a printf on this. This is a good experiment. Printf. We can get lots of options for this. So let's just go ahead and do the v here. Like I can't find funcs. All right, and let's go ahead and run that. Cannot find funcs. Go init mod. I don't know what to do there. I kind of wanted it to be in its own package, so I'm gonna do something you should never do. I'm gonna use a local import. Do not do this at home. This is only for testing. Oh shit! I was afraid of this. I was dead wrong. I was confidently and horribly wrong. You can't hash a string type. Fuck. How's it going, Dennis? Um, do not do this at home. You can't. Yep. Fuck. Fuck, 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 fuck. Well, so much for that error approach. This is not my problem. This should not, there's no reason they had to make it that way. So, in case you're coming in late, I'm doing a little test here. So, I have a situation where I want to be able to look up, I want to be able to create more readable names or have like names for a given function. And I can provide aliases and stuff like that. But I was super, this should not be a fail. I should be able to take the symbol identifier. This means we're going to have to use anonymous functions, or we're going to have to take references to functions to store those instead. Fuck. And that's totally fine, but my God, am I glad I did this as an example. Because I can't actually take an underlying pointer reference and build my own symbol table. I'm okay, Angry Moose. The difference is that this forces a very different architecture for lookups. And you guys might be wondering, well, why am I stressed about that? Well, I'm gonna show you. So what we're doing here, the whole point of this, one of the biggest reasons for the refactor, have problems with this, yeah. Well, Python's even worse. I mean, let's just be real. You can't even do an anonymous fucking function in Python. It's so fucking brain dead. Or switch. So yeah, what I'm about to do can't even be done in Python. And don't give me the shit about lambdas. They're not anonymous functions. I don't give a shit. They're not. They're one-line excuses for white space because, all right, I'm a little bit triggered, but if you do want to have an absolutely hilarious laugh, do the research. And I've talked to Remingo's heard this before, but go do the research and go find the thread with Guido van Rossum and the gang trying to figure out how to do anonymous functions and punting at the end because of white space because they couldn't figure it out. I knew lambda was going to come up. Everybody brings them. Yeah, it does lambdas. Oh my God, no, just no. Anyway, so the reason I was talking about this, so this is kind of for the guys that are on the team and are wondering what's going on and why am I freaking. So this is pretty big. So Greg, if you're there, Quint, if you're there, put yours on because this is going to seriously change the core architecture of the reference library. I'm not being overly dramatic. It's totally doable. It's just going to have to be completely different. We're going to have to create our own dictionary. Our own dictionary is a logical, data type. It's not a thing. It's a map. But we're going to have to make our own lookup for first-class functions in order to get decent error messages. And the whole point of this reference thing is I want to be really excruciatingly cognizant of error messages because this thing is going to be used a lot, and not having really great error messages is going to be a problem. In fact, having great error messages is what triggered. We had the whole thing working, and it's still working, but the great error messages is what triggered all of this refactor. Because that meant I had to start giving internal knowledge of the grammar to the parser and to the node tree model, and I wanted to do that without creating a really tight coupling dependency in those things because I want to be able to use them for other things. Maybe I just need to throw my hands up in the air and be like every other fucking parser and say, oh, I have intimate knowledge of this grammar and this grammar only, and then be able to plug and play with the grammar. But that's kind of what we have now, so we're good. In other words, the way the grammar works right now, I mean the parser and the node tree, is if you don't have a reference to a particular grammar, it'll just show you the one. It'll show you the integer that goes with the node type. But here's where we get in trouble with the parser. And it's not in trouble. It's something we can work around very easily. But it's just annoying. And that's why I'm glad I checked it. And I had my spidey sense was kind of going off this morning. And I was like, no, I'm pretty sure this is fine. But I'm going to check anyway. And sure enough, can't be done. So my spidey sense was right. So this is what I'm talking about. Oh God. All right. So parser. So the most important part of our parser is the expect line. This is where we implement our pseudo syntax. And here it is. And expected is this error message handling that's built in here. It gives you really detailed messages. And so I've done this was done in another video, afternoon mouse. But here's the problem. So if it's a rune, it's a string. The error message is very happy. It's a happy little error message, right? And it says, hey, guess what? I was expecting this and got so and so, this and such, And where's my definition? Here it is. So you see these, right? So that's great. So when I come across, when I hit the rune or everything is a decoded rune at some point. So every failed expectation is always, while the parser is on a single rune. And so then the question is, well, how do, I expected a string. Okay, here you go. Right. And it'll say it expected a string, but it was, whatever. You can say here I expected a rune and I didn't get that. And then here, any of the other types, it'll say, oh, I expected this, I didn't get it. And that includes like an is.not, and all of the pseudo syntax structures that I have. So like min, max, min, all that. They will all pop up here, and so that gives you, as a grammar writer, that gives you a little bit more hint. And what the heck? So that's all well and good, but the problem we have, and this is what triggered all of this, is with first class functions. So the use of is functions, the use of what I'm calling parse functions now, and check functions. Actually, check functions are the only things that come to expect. Parse functions don't call expect at all. They use checks, which call expect. And so if I pass a check function, which can either be so a class is a function or a check is a function. This is either, if they've cast it, it'll work. But if they don't, if they just have the function signature, it'll work. This is int32 is the whenever you use the term rune, you're actually referring to an int32. They are literally synonymous tokens. Anyway, so we have this casting going on, but here's the problem. Now, when I come up to do an expect error, right? The expect error's got this big long under the where it says type. After type, it's this big, long, frickin' function signature. And that's not useful, right? And by the way, even if I could get the type, what would it be? And I got it to do this, by the way. I got it to do it would show pegn-class. I was like, well, okay, well, which fucking class? Which check function is the one that failed? So it doesn't give enough information. Hey, Sarchini. So what we actually have to have it do is we have to be able, the expected error message printer thing has got to be able to look up the verbose explanation of what that thing is. And frankly, it shouldn't just be the type. I should be able to have the freedom to say, oh, well, you had one of these type of things miss. Therefore, let me give you a verbose little error message in your errors, possibly, that really tells you how to do that, what that thing is, where to go get more information about it, all that stuff. I don't necessarily want to do all that, but I want to be able to do that. Right now, the best I can do is give them this function signature in this cast here. It's the same sort of thing they would see in the error message. So to remedy that, I'm like, okay, fine. We got to make our own sort of symbol lookup table, and that's what I just tested. All right. So, and that's what I just tested. I just tested how I would do that. So, this says, okay, I'm going to try to print up funcs.sum, and It apparently does not do that. I want to be really, really sure of this test. So I'm going to go build and run it this way. I think it might be because when you do run, it doesn't pull in the libraries. Nope, still there, unhashable. So yeah, yep. Line 12. I cannot. So this tells me that even though you can use any interface as a key, Go puts its foot down and says, you cannot make your own symbol tables. Perl let me do that, no problem. I did it actually. So I implemented the Perl classes program, which is kind of so you can get underneath the hood and do stuff like that. Apparently Go told me, nope, can't do it. Because here, this assignment here, this is the one that's failing. I'm almost positive, is it not? Line 12, right? Yep. It's like, sorry, can't do it. And it's when it saw this that it really freaked. Now, if I were to, I mean, maybe if, I mean, here's what I can do though. And this is kind of what we're going to have to do. Unfortunately, we're gonna when we do our, see, the reason this is so important is because this is going to directly affect code generation. So rather than creating functions that are, we're going to have to take references to the functions and do that instead. Did you say Joe? So let's do this. So if I do, I mean, I don't know if I'm gonna try to break this. Let's see how this looks. So I'm gonna say, let's do this instead. Let's do some bar some. This is like very JavaScripty, right? You know what I'm saying? Is this not JavaScripty or what? Can't use Walrus, of course. I'm so dumb, Rob. So this is fine, right? And I actually think this would work. This is gonna freak me out if it works. Whoopsie. I want to make sure that. Nope, can't hash it. Shit. That is not good. That is not good. That's not good. That's not good. That means I'm going to have to do in my pseudo syntax, I'm going to have another type for that kind of thing so we can encapsulate it and trigger it. Fuck. Oh. Which doesn't make me mad. It's just not going to be as elegant, but it's going to fundamentally change the pseudo syntax. And that pseudo syntax is written in all of the checks. So yeah, this is quite an effort, but I'm glad we're hitting it now, because this would have affected how we dynamically communicate information about what failed to match and what grammar things didn't work and stuff. And I was kind of being overly clever, honestly, by using first class functions on that, and I still will. It's just that the first class functions are going to have to be wrapped in structs of some kind, and then the struct is going to be the trigger for the type, and then I'll just grab the function out of it, which is, not as cool. In fact, it might be slightly slower. I don't know. It's not any slower than the other stuff we got going on in there. So anyway, unless I'm missing something, I really, really want to be missing something here. But the error that we're getting the error is very, very explicit. The error is, I'm sorry, that is not a hashable key type. That's not like you're doing the syntax wrong. It's like a no. Function references cannot be keys. And that's just not cool. It kind of pisses me off. All right, I'm going to find a way around this. So if anybody knows of a way around this, let me know. I can't even print it. You know what I'm saying? That's like so uncool. All right, so let's I don't know. Let's drop this for now. Get that syntax. You know what? It compiled though. That's what's making me nut. Wait. It hasn't. Wait. Hash on the hashable hash interface. You know what? Wait. Yeah, you can use function pointer as key. Yep, you can. You should be able to. That's what. But there, I'm trying to figure out. I think the reason this isn't working is because. Wait. Is function. So this one is here. This is an is function. I know I could have like an is function. I wonder if I did this. Oh, I wonder if it's just a syntax error. Go build. Invalid map key type is function. Fuck you. So Golang. Functions as map keys. The key type must not be a function. Where did you say that? Must be a function map or a slice. That pisses me off because I can do that in JavaScript. Thanks. I was just looking for it. Fuck. I could have done that in C. I could have done it in probably I could even do it in Rust. Yeah. No, that's fine, Dennis. It just what it means is that that they have limited Go in ways that other languages are not limited, which is for probably best because it's a little bit too clever. Yeah, and I can get around it, but yeah, I mean, because look, this would have been a no-brainer in C, because I could have easily put a pointer function in there and it'd been fine. But then again, in C, you can't switch on type, so I would have had to write my own lookup for that. But that's fine. I actually thought maybe it was a thing. So yeah, there you go. There's your answer. So there you are, world. You cannot use functions, function signatures, maps, or slices as keys in a map. Yeah, we're gonna do the struct wrapper. That's what I was just saying. Yeah, we have to. There's no way around it. Cannot switch on type. Let me ponder a way around that. Well, it's actually they don't even support maps with function identifiers. So Dennis, the takeaway from this, the takeaway from this is you cannot use a function pointer as a key in a hash map in Go. The end. And you know as well as I do, you can do that in C and everything else. So that is a limitation I was not expecting to hit. You can even do that in JavaScript, but you can't do it in Go. So lesson learned. I'll have to write that down. This video is out there for people to go watch. That does mean that I'm going to have to wrap it in. And thank God I have that. I am awake, of course. Hi, Z. And so JavaScript, does someone say Jehovah? Yeah, it's like, whatever. Let the stoning begin. So here's what we have to do here. This code right here is going to have to change. And I'm no longer going to be able to switch on function types anymore, which is probably a good thing. It probably is a good thing. Lesson learned remembers me for big blue terminology. Go Coffee Maker Last Miles. We just got a new one. It's kind of retro-y. It's a fun one. Rust match with enums. Well, yeah. I mean, we could totally. There are so many other ways to do this. The reason I did this little experiment early this morning is because before I, bet the farm on switching on function types, which you got to think about that for a second. That's pretty damn cool. This is the thing that seems a little bit hypocritical for Go on my part for me. Go will let you switch on function type. And if you're new to Go, you may have never heard of this concept, but there's this thing called an empty interface, which is an untyped thing. It's actually a typed thing, but it's like making a hole in whatever your function signatures are, so you can put whatever you want in there and then deal with the type later. And the reason that generics are getting so popular now is because some people are annoyed by this type switch that you have to do this. It's very Go only. I've never seen anything like this in any other language. It's actually really cool. I like it because it gives you the flexibility of parameter signatures that you get with something like Python, but with the strict typing that you need, and then you have to do casts like this. So that's really awesome, right? So but the thing that seems sort of hypocritical for me for Go is that they do allow you to type switch based on functions, right? So that means that they're allowing you to look shit up in the underlying symbol table based on that and say, oh, this is this type of thing. I want to do this stuff, even though there's a cast here because either of these would fulfill it, whether it's referred to as a a type that's on top of the anonymous function or not. I mean the first class function like this. But then you can't use it as a key. And they're saying you can't use it as a key because you can't cast it. So whatever. The way around this is this code right here. In fact, I'm gonna have to put that here. So fix me to use type instead, and this one's gonna have to change too. And that's fine. In fact, it's like kind of full circle because I didn't even add this like pseudo syntax until I started realizing that I could type switch in here on my expect, and I could really, really, really simplify the parse functions or the check functions, both. And so in doing that, I ended up making this, right? So you got all these different struct types, and then you can like mine the struct to see what's in there, right? Another thing that's going to do, what? It's not going to be too bad. That's going to free me from this crazy cast right here, because it's going to be in the struct. It's already going to be defined as a specific type, and that's not going to be needed. It's already going to be cast. It's not going to be an interface or something like that. So basically, it's going to give me more specificity in the type switching, which is fine. So this might actually turn out to be a better thing. But I wouldn't have even thought to do these like pseudo structs that indicate some change to the syntax about what you want to do with the data in the struct. I wouldn't even have thought of that if it hadn't been for switching on first class functions and thinking, hey man, I can switch on this. Hey Mark. So yeah, so we have isMark, we have isCount, we have yeah. I you know what, Z, when I port this, I'm gonna port all of this as soon as I get this done. I'm a sadist. I'm gonna port all of it to Rust as one of my, I don't know when. It'll probably be my first significant Rust project, because I do want a reference library in Rust as well that does this, and I can't wait to try to do enum switching, because I think it's the closest thing to type switching that exists. Basically, I want to see if it's even possible to write an expect function in Rust based on what I'm doing here. It might not be, because this is really fundamentally tied to type switching, and I don't know if that can be done. Anyway, so we have isCount. So all we're really going to be doing is creating another type. And yeah, so and frankly, that's fine, because it's ironic, because I already have created this. So yeah, you know what? This is working out. This is working out for the better, actually. Because as I was trying to like put everything together for the grammar into a nice organized place, I started to put everything inside of this grammar subpackage or library, and I'm not keen on Rust. But look, guys, everybody thinks they don't like Rust. I don't believe Rust is the best pick for most applications, as I've said over and over again. But I'm not, and I hate its syntax, but it still might be the best language for certain things, as I've said before. Alacrity, blah blah blah. Anyway, but that's all I'm saying about that. I've told everybody should learn Rust, whether or not you use it, because it'll make you a better programmer. I really truly believe that. All right, so this is actually kind of coming together in a good way. So I have these like sub packages which have the pieces of the grammar that have been dissected into their Go code that would be created by a generator, and the TK is the tokens, ND is just the IDs with their lookup. His functions are the is functions are all of those class functions. So you know, you got, well, yeah, so here they are, and here's how you wrap up, pardon me, so here's how you wrap up the other stuff. So you say I have a min max or whatever, but here's what a true is function is. So that actually, these should probably be separated out, frankly. um I mean, they're yeah, no, I'm gonna need another is function, god damn it. um I don't think these is structs go with these others down here, but that's okay. Anyway, so the alpha. So if these are all these functions are being passed, and those are the things that are being looked up by the um, by the parser expect function. So if I come here and I say, do I have a class function? Yep. Where is it? So so here it is, a function boolean, right? If I have that, here's the code I run. It says, oh look, I expected a v. Otherwise, you know, see if you have it, and then do your thing. And in order to tell whether you have it, it actually runs it. So it runs the function to tell if it's right. And those are all just pointers and stuff, so it's not that slow. Anyway, so that works really well, and that will continue to be an is function. So that's what I'm talking about. So these things, though, there's no way to identify them as there's no way to identify them. So I'm actually just playing around with this for a second. So I might have to do something like this. Wow. I just make them all structs. Yep. That's what I would do in C. So you type alpha is a struct with a first class function in it. Yeah. Wow. This is gonna work. This is very C-like. And I could have an is function, so I could have no, that's not gonna work. We have to say that the alpha struct is no, is that gonna work? I don't know if we're gonna make them no, God, no. What am I doing? Oh my God, that's so stupid. No, cannot do that. I got to make it a member of a different type of struct. So these all got to be members of some sort of is struct. I'm going to say class. So yeah, I'm just playing. Don't nobody freak out, but I'm playing with what this is going to look like. So it would be is. So we had a type class, and the class is a struct, and the class has what in it? The class has a first class function. And yeah, and the first class function will be an is funct. I could probably, you know what? I could probably just embed that. Where is that type defined? I don't remember. I think it's at the high level. I might have a circular thing here going on, so I don't want to do that. A circular import, it's like when you have stuff in one at the top level and also the bottom level, and yeah, it can ruin your day. Grammar.go, so we have a check functions, and a class. So yeah, so I already have a type class function. So I wonder if this can be circular. So this class could have a pegn class, which is a function, and that's it. Holy shit. Yeah, that's it. That's it. Hi, Paul. Um, oh my God, this is wonderful day. It's a wonderful day in the neighborhood. Um, yeah. So we're gonna have like an is alpha. So that's the real now it gets interesting. So what is an alpha? Let's actually try that. So alpha would be um hmm, alpha alpha would be a struct. Really, that's the only thing. I mean, it's like okay. Um my turn. You're seeing Mr. Rogers. Well, it just turned out to be super easy to encapsulate the first cast function inside of a struct. So I have a feeling I can transform these types without much change. It will be different. It's really important that I go through this part of the refactoring. It's going to change every parse function I have. I have like 80 or 90 of them, and it's also going to change the generator. So when Quentin wakes up, he's going to want to know about this. But I really love this because this is totally compatible with C. So if I were to write in any other language, it would be it's not as wacky Go specific. No Unicode at all. Hey, which one? Any return? Yeah. If there isn't any Unicode code point, yep, except for in Yes, sirree, Bob. So yeah, I disallowed that once, but I might change that later. What I'm trying to get my head around here is what this would look like. So alpha's going to get redefined as a struct. So it would be var alpha, and we'll do it like this. No, I have to do var alpha equals a class. Oh God, it cannot possibly be this easy. No symbols line, Etsy, okay. Oh God, I'm getting backseat driving from the master. Pure ASCII only and no symbols. What are you talking about? Me? Pure ASCII only and no symbols. No, this is different, Mr. Last Miles. This is me qualifying dot from Mr. Brian Ford, who decided to just leave that hanging and not tell anybody what it was. This is hardly ever used. Yeah. No, this is a class. It's a class of characters. So if you use the term any, then everything is included in there. Yeah, I have other classes for that. I have like, the traditional alpha nums, the POSIX stuff. And when I say class, by the way, boys and girls, I don't mean object-oriented fucking class, okay? I'm talking about class of characters in the POSIX sense. Yeah, I don't know. You get to speed on Go anyway. Yeah, just take your time. There's no rush. It's a fun language. I really like it. It's very, very workhorsey. Believe it or not, I think I can get away with this. I'm about to be a little bit shocked and amazed by Go's coolness here. And if this is all I have to change, because this is still in the declaration space, I don't have to do any fucking fancy init stuff. Oh my God, it took it. Yep, that's it. This topic again. What? Sorry, Mark. I gotta write stuff. Don't you like it? It's a fun topic, right? But this actually made me very happy because I think that, goddamn, I think I just did it. Now I can, if I need to put this in the map, so I can say, what is this alpha thing? No way! I can actually. Oh, 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 oh. do 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 do. You should realize what I can do, right? So this can be a class can have a class in there, and I can have a description. No, God, I don't know. What should we call it? Name. Well, yeah, we have to have a name because it's just a variable. So we can give it a name, and the name can be a string. What just happened? Except for that, that's a fail. Can I put those on the same line? No, I cannot. Silly boy. So there, I just solved my own problem. So now I'm sending around a class function, and I'm also sending around its name. I could put the full fucking description here if I wanted to. Yeah, I think I'm going to. Why not? Because it won't. It'll just be nil. It'll just be empty string. So this is so cool. So this is so much better than what I had. I'm so happy that we went through this. It's like when you accidentally delete your term paper at the end of college and then and then you like redo it and it's better and you get a better grade because you did it all through at once. So yeah. Yeah, name, rank, and serial number. I'm like way too happy. I know it's probably disgusting, but this just made my day, man. Yeah, I mean this really just made my day. So yeah, oh, people can give me shit about object-oriented programming. That's object-oriented programming you're doing there. I'm like, oh, I know. What I'm doing is I'm encapsulating a function with information about itself so that it can be used as a proper argument parameter. I won't say object, I refuse. But that's what it is. So, it's actually not really an object. It's a struct. It's exactly what it is. It's a struct. It is a struct, people. That's exactly what it is. In fact, fuck. You know what this means, don't you? I think I should get rid of this. Also, I think this should go into the top level because it's a type. It's a grammar type. So rather than have the class, yeah, all right. I know I can see the end. I can see the promised land. Some long and awesome description. Okay, so yeah, okay, so that completely solves that problem. But that's going to make the parser look very different. I mean, it's going to make the expect function look very different because instead of this, I'm now going to be switching on. I'm so freaking glad we got that. So instead of this, I'm going to be doing. Oh, actually, no. Whoa, it's going to simplify this. It's going to be this instead. That's it. Holy shit. So it's going to be that, and then it's going to be v dot func. And then when it gets it says expected v, it can like grab the error message right off of it. It's perfect. It's a perfect plan. And everyone's like, well, that was the obvious solution. You know what? If that's you, pat yourself on the back. You are a better coder than me. So yeah, I'm super happy about that. In fact, I'm so happy. I'm going to take a little celebration. That's actually going to simplify my code here. It's going to simplify the error messages. You know what else it's going to do that just really, really makes me happy? It totally opens up the flexibility to change it to something else later and to make an unlimited number of different types of function-based checks. And that's fucking awesome. That encapsulates the encapsulators. So I'm going to go get coffee. Obviously, when I come back, I'm going to play with this some more. And And you there's your fishies, nice fishies. I'm gonna be a few minutes. I'm gonna have some breakfast and come back. I'll take my beer bottles downstairs. You know, I gotta be a good. I have to be a good coder. That's one reason you won't see my cave. I'll come back. When I come back, in case you're wondering, uh, I am going to be refactoring that thing. You know what? How long am I going to be gone? I might as well just, let's see. Should I drop the stream? I'm wondering if I should drop the stream. I'm trying to think what I'm going to do when I come back. So when I come back, I have to keep doing the refactor. So I really don't have to change the stream title. So I'm just going to keep the fish on, which means I'm just going to go get coffee and toast. I'll be back in about 5, 10, 15 minutes. I don't know. It depends on if my wife starts to talk to me. There's lots of factors that are involved, so I'm not putting a time. I refuse. All right. So thank you, and talk later. All right. In terms of buffering, so hey, people, in case you haven't seen, there is a YouTube channel now for all to enjoy that has better transcoding and all the rest. So, just letting you know that. So if you want to, I have not yet figured out a way to, just letting you know that. Hey, look, it's not even that laggy. There's nobody in here, just me. But if it's easier for you to get transcoding here, which you can do, right? So you can get any kind of playback quality you want. And that is not possible unless you're a partner on Twitch, which is why I threw my affiliate in their face. And I'm like, I don't care. So, I mean, I appreciate what Twitch is offering the world, but that was, and I get the transcoding takes resources, blah, 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 blah. I get all that. But it still kind of annoys me. Anyway, so we're going to leave our YouTube in the background. And back after I finish all my other important stuff, we'll go back and create a Restream API for talking to that. All right. So while this discovery is fresh in my mind, it's just not guaranteed. Yeah, it sucks. And I'm just tired. Hey, Eric, I'm just tired of people complaining, sort of beginners particularly, or internationals are like, I can't get the transcoding. You forced me on 1080p, you bad person. I'm like, I have no like that. I don't have any choice. They just do that to me. All right. So based on this recent discovery, I'm going to go ahead and spend some time revising this parser and testing it with the new struct stuff. So that's the part of it, of course, 1080p is low res, maybe for you. I refuse to there's no point in me pushing 4K. My monitor is not even 4K. My monitor is 4K, but my desktop is not 4K because Linux still doesn't do well with 4K. I have a 4K monitor. I don't need 4K. I stare at a fucking terminal all day. I don't need a 4K Groovebox terminal. Linux works with no, it doesn't. No, it doesn't, Mac. I have objective evidence to the contrary. Yeah. No. There is a lot of 4K. Look, it works with 4K, but the applications don't support 4K. They don't. And there's a setting you can go in and change it. And you can go in and change the 4K. You can go in and change some of the things to auto double and all that stuff, but yeah, all your applications. But there are applications that one of them that I know doesn't is KeePassXC. It's kind of annoying. I mean, I can work around it, but honestly, I don't need it. And pushing a 4K stream is sort of irresponsible to me because I don't need it. I was kind of okay with the 780 stuff for a while, but that was way too grainy. So, I can't complain about the butteriness of Alacrity versus, or not complain, but cite how well Alacrity is like. I switched back to GNOME Terminal, by the way, from Alacrity, and then also push 4K that's jittery just because of the memory constraints on it. And but anyway, that's just me. That's not that slow. All right, so we're incrementally putting all the pieces of the parser back over. I'm sure it does, Mac. So you can look at your pictures of your pork bellies on your 4K. It is smooth. So is mine. You know what? My biggest problem right now is my eyeglasses. Yeah, I've let my eyeglasses have this stuff on them. I need to go get new ones. But I let the covering on them get bad. So they're absolutely horrible. They're so full of blur. I can't wait to get new ones. It's going to be such a such a fun thing. Um, when I left the pagan, when we last left the Go pagan library, we were in the middle of incrementally bringing stuff over and creating a new parser. And incrementally, you can't get laser treatment. My corneas are too shallow. Yep. So sorry. I wouldn't do it anyway in 50, lose it anyway. Everybody, I know so many old people who got laser treatment and then they had to get bifocals because their eyes got old. Yep. So not a fan. Bo, 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 bo. We need I need to go find my old stuff again so I can parse it over and bring it over. And we're gonna bring this over. I don't know what piece to bring over at a time. We were actually defining the grammar, if I remember right. Let me go look again, because I have to know where I am. Git status. Everything new over here? Yep. Has this not been committed yet? Git log. How far into this am I? I can't remember. This is why you should finish your projects rather than moving to the next one. Legal modules, permissive legal files. Okay. So I think we have all the stuff actually working and being here. The grammar. So we're actually not going to call these parse functions anymore. This is all going to change. So yeah. Sigh. I'm trying to decide which part of this to do first. I think the node tree would translate more directly without any external testing. Yeah, the node didn't look up. We still need that. Greg, is Greg there? Greg, have you got a sort you want to write for that node didn't look up? If you want to write that, let me know and I'll just put it in there. You can commit it or whatever. So if you want to write a sort of some kind that goes through a map of strings and gets you the first match and returns the integer that goes with it, basically it's a hash algorithm, reverse algorithm, hash lookup algorithm. If you want to write that, you can do that. It'd be a fun one. I kind of want to do it, but all we take is just a bunch of strings, and we look up the string that matches the argument, and as fast as possible, there's where the algorithm comes in, and we return the integer of that index, whatever position it is in the array. So that's what this needs to be, rather than make a map of node names. Yep, do a map. No, it's not a map. No. That's the point. So it's just this. So we want to take a bunch of node names that are just a slice of strings, essentially a string slice an array. And we want to look through this and find the first one that matches. Yeah, that's all. As fast as possible. So quicksort, maybe, however you want to do that, whatever algorithm you want to use. There's how many umpteen algorithms are there for that kind of thing. You might want to look through the different ones just to kind of get acquainted with them again. I just actually read about them. Kind of renewed my interest in those traditional computer science things. They're in the first chapter of algorithms. So they are right here. Nope. First algorithm design, randomized algorithms. Nope. There they are. Data structures. Okay. Well, we got all the data structures. Linked lists, hash tables, trees, heaps. There's certain actions, operations. Insert, traverse, remove, count. Public interface. There's actually a name for them. Formal algorithms. I think, maybe I'm confusing it. I thought that they do list them. Here, there it is. Randomizing algorithm in quicksort. Quicksort works as follows, blah, blah, blah. divide and conquer algorithms, merge sorts. So yeah. Anyway, so they're in this algorithms with C book, which is kind of fun. All right. I'm feeling a little overwhelmed at this point because I'm doing a lot of refactoring, and I'm also got some stuff that I'm going to be changing. Is for free. Yeah. Tell me what you like in that book. I really love it. I love his practical approach. I mean, it's very dated, but it's stuff that doesn't really change. So, parse functions. So parse functions are a thing. Check functions are not a thing. I'm going to have to change all of this. Yeah. Let's see. I need to redo some of that writing, but look at you. Who says you don't get anything for free here? I'm sure Kyle doesn't care anymore. The author. He probably stopped getting residuals a long time ago. Yeah. Oh, wow, look at that. Some bits. I think you're not going to be able to give me bits later after this whole thing changes. All right, so I actually already did this, and I'm going to go grab it from the other one that I was kind of just riffing in. Fuck. So let me go find that. I was in the, what was it? It was in the is functions. Yeah, there we go. So this is what I need right here. This needs to come over. Yeah. Oh gosh, so much to do here. I gotta start focusing, guys. So, this is a class let's do called a check. So is that check? Pegn check. No, I'm getting rid of it. Oh, did they finally? Yep. Yeah, I asked them to drop my affiliate. That's great. I'm glad they did. It's because I'm restreaming, and you know what? It's better for the world. If you want to help me out, I wish there was an easier way to tip me, and I'm not gonna do the fucking restream thing. Yeah, people aren't gonna find me as easily, but whatever. I don't give a shit. I got shit to do. So we're gonna say, he just typed it in, didn't he? I was gonna say, restream it first, but I was just setting it up, created. Yeah, it's fine. I don't mind at all. The main reason I'm doing restream, just so you know, is that it's not going to create a segmented audience because I'm going to make an API to the WebSockets thing. It's going to put it all in one terminal, so I'll see everybody's chat. That's coming. That's something. In fact, we'll write that, Eric. Let's write that and go. That's totally doable from everything I've read so far. So it's just a matter of doing it. And so yeah, I mean, my audience, my YouTube audience is over here. There's not many. The fish are gone. Hi, racing team. Yep, they're gone for right now. So, you know, we used to joke about that, right? So, but yeah, the main reason I'm doing this, by the way, I got to get back to focus, but the main reason I'm doing this is because YouTube has way better transcoding. It's permanent for everyone. It doesn't have any limitations on storage of videos permanently, and it automatically creates the video and stores it for every live stream. So I do nothing. I literally do nothing, and I'm able to make videos as fast as I want by pushing one button. I change the titles up, done. So the only downside, of course, is that I can't read the text coming in from my other streams, but they have an API for that. I just have to do. All right. So a check, we have a checked, whoopsie, we'll check the check func. And so it takes a parser, and we have a mark. That's all good. So yeah, and then what? All right, so let's see here. I almost don't want to write that right now. I'll come back to it. I mean, the whole point of this is that I don't leave anything. Daddy, I love you. Hi, Tori. Check. Parsers check functions. Let's see. Are encapsulated in their own struct so that more useful information is available in error messages. And let's see, and other types of messages. The function takes one parameter, a parser, as its only argument, and can be passed to expect and checked methods. But returns a pointer to a mark instead of a pointer to a node, but returns a pointer. And returns a pointer. You love me so much. I don't even know you. Thank you, though. And returns a pointer to a mark. Or nil. And any SA. Mark is nil and error is set if something goes wrong, including failure to pass the check. Do 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 do. Bump boom boom beep bump bum. Oh, you like the Red Sox? Yeah. Yeah, that was a fun time. That's a fun Christmas. It feels, my wife's like burning the candles already. It's like, yeah, we're back up to Christmassy kind of stuff coming already September. Will you be quiet? Also, your beard. Okay, Tori. I appreciate it. I appreciate the vote of personal confidence. Check functions are encapsulated in their own structs so that more useful information is available in error and other messages. Are you Otto? Are you like trolling me downstairs? The function takes a parser as its only argument and can be passed to expected check methods and returns a pointer to a mark. Mark is nil. An error is set if something goes wrong, including failure to pass Check functions are therefore, by Tori, check functions are therefore lighter than parser functions and are actually called by a parser function to identify a node. If a match is found, let's see, when a match, when a match is found, a mark pointing to the last rune in the match's return, such that the caller can call, let's see, such that parse can be called reliably to return the matching string, which is what most parser functions do. Which is what most parse functions do. It's a problem with writing documentation too early. If you write too early, you end up having to redo it all. It's kind of annoying. But so yeah, func name and description is a lot better. Lots and lots better. So parse functions do not have to. You know what? You know what we could do here? Yeah, I wish Quentin were here. If we do the same, parse functions are not necessarily the same, but if we did, we can do the same with the parse function and provide all kinds of information about why that parse didn't work. I'm really feeling the call to do that. That would mean, I mean, it's not even, it would give us a lot of flexibility. So right now our parse functions are kind of, so this is the thing. This is, God, we got it. This is fantastic. Because, we don't have any way to give any information programmatically to the error messages and to the output that goes with the function. And basically what that means is that all of these are just mini parsers, and that they have their own information about it. And you know what? I don't know why I didn't do it as a struct in the first place. I definitely don't want to make it an interface, because then, no, it's like, I think an interface is too heavy for that kind of thing. But if we do this, then we can actually alter the structs later and give them more information about it. So that means, for example, we could include a field called pegn, which is like, no, this parser represents this pegn notation. God damn. That's a holy fucking grail right there. And then we don't have to even put documentation on the function itself, because it's been embedded in the function, because it's not doing us any good. Like, because it's we want to use it in applications that use the parse functions, not force somebody to go look up the docs. So this has been a really good change. And yeah. Check functions. Let's see. Check functions are encapsulated in their own structure, so that more so more information is available in error and other messages. The function takes a parser as its only argument, can be passed to expect or check methods and returns a pointer to the mark. If found. Mark is nil in error. When not found, a nil mark and error are returned. Check functions are therefore lighter than parser functions and are usually called by a parser function to identify a node. God, you know, I could actually... No, we can't force that, though. I was thinking for a second we could actually force parse to have a check function in it so that every parse function has a check function. I'm not sure we can actually say that. When a match is found, yeah. Let's see, the mark reliably which is what most parser functions do. All right. So yeah. Wish I could dump what's in my head out on you right now. I can't. So when Ethan's been finishing the check functions, and almost all of the check. Another thing, that reason we're doing this is because the parser functions are almost entirely one for one with the checks. And the only difference is that they call the check and then they return a node or not instead of a mark. That's it. So it's almost like we could do this instead. We could almost do this instead. We could say type parser, and well, that's gonna we do type node parser, as a struct, and then we would have the function, and the function would just be this parser pointer to a node and an error. But we almost don't need that. Huh. So, yeah. This gets weird because I could actually... This kind of gets back to what we were doing originally, and I'm kind of departing pretty radically from everything. At one point, we had it so that was an interface, and you had implemented the parse. anything that implemented the parser thing. But if you do that, then you have to turn everything into a struct. You can't just have a function, which is what we just did. So if you're going to turn it into a struct, you might as well make it fulfill an interface. Um, um, fuck. Folk. No, you can't do that. Because you wouldn't know the parser. Um, yeah, I'm just trying to think here. So that would be uh I'm just trying to think here. So that would be what? We've made it a receiver. And we did this. We did fuck. I don't want to get sucked into this world. I'm just playing here. I have to be really careful though, because this could easily like really derail me, and I don't want to be derailed. Um, fuck. I just don't think it's fast enough. This is the thing. I don't want to get too big here. Because the obvious follow on to this is to make this into an interface. And then just have anything that fulfills the interface. Does the interface, is the check have a name, a description, and a check function? And, you know, the fact of the matter is the name and description don't get looked up unless it's in an error message, so making an interface would be totally fine. And, you know, then you could have whatever other things you wanted inside of it. Fuck. I feel like that's what we need to do. Unfortunately, I really do, because then anything can fulfill the check interface. That goes for the class stuff too. That's gonna have to change too. This is actually really important. I'm gonna get rid of this stuff. It's like it's a pretty big change. So I'm really gonna test this out. It's like lots of changes at once, though. All of these things are going to go away. So, and then we don't need that. We can just have a node parser interface. So this is an diagram. Okay, all right. As you were, and then yeah. And then anything just has to fulfill the interface. We don't care what it is because it's already a struct. So we had to bite off on the struct in order to get the information about the function that's being called, so that we can reverse look up its long form for the error messages. Therefore, we have this sort of OO concept that's sneaking in, and that means we might as well just make everything an interface so that we're doing it right. And this is a good example of something that does need to be an interface. I would hesitate because it might slow things down in the parsing, except for the fact that calling the function is no different, and the name and the description are not used. They're not accessed except for in error messages. Therefore, they don't need to be high performance, which means that they could, this whole thing turns into an interface, right? So let me show you what that means. So I'm going to get this off my chest before I move on. That means the check is now something like this. I was just going to change everything. But we do type check interface. And we have a name that returns a string. We have a description that returns a string. And we don't care about the order. Frankly, we don't even use the thing. And yeah, and then what? Then we have a check. A check function. And yeah, so does it build a checker interface? I guess we could say, does it build a check interface? Is it a check? Yes. Hi, purple pineapples. And then the check would be, the check needs to take a parser, receive a parser, and it returns a mark and an error. And then we got our OO going on a little bit more. All right, so yeah, that's really the way to go. I mean, let's just be real here. That is the way to go. We already have a parser. We're gonna have a node parser, which is the overall parser. So when it comes to node parsers, we're gonna change that too. So we say type a node parser. So it's kind of a node parser is a breakdown of the larger parser, and we'll give it a parse function. So parse takes a p and does the rest. Ha! I said takes a p. I said takes a p. So yeah. I think we've got what we need here. So parser, we have a node parser. We can actually add all kinds of fun stuff to this later. It's a string. Does it have a name and description? And yeah, I'm gonna put in here. I'm gonna put peg. So the pegn is the actual string notation for the pegn. I'm gonna put this down here too. So yeah, that works out. This returns a node. Let's have a mark. So what does a class function do? Now classes are a little bit different. But they still need to be encapsulated. So type is a class. So we have a class there. A pegn node parser. All right. In which case we are going to make this let's see. I'm going to say it has an is function. Yeah, let's do this. Is is a member. Okay. Yeah. It does mean that all the Unicode stuff, if somebody wanted to use it, would have to be encapsulated, which is fine. Because if somebody's going to use one of the Unicode things, they're going to write a pegn grammar for it anyway, and they can implement it by having it just return the Unicode code plan lookups. So the is functions would just be implemented that way. I'm going to actually make a new interface for this called grammar type grammar grammar component, and then I can do this. I can say it should not be, well, it can be first, doesn't matter. Grammar component. And yeah, I know purple. We're going to get there. There's JSON destructuring, so nice. Ooh, yeah. Hang around Discord. I don't, yeah, I mean, we're kind of, I have 4 merge commits that I'm trying to get in that are gonna be significant. So I'm really going as fast as I can to open up the way for other people to commit. And I also have like 2 or 3 projects that I think other people could help with. So like the whole Gits project, which I did videos on yesterday. If you're interested in getting into GraphQL and stuff like that, you might want to take a look at that. And maybe that one is almost ramped up enough that we can have people start coding the different use cases for it. So like the scaffolding is all there, and we just need coders to fill in the gaps, like for create, merge, issue pull, and things like that. So anybody who wants to, that's going to be largely a busy work kind of situation. So if you want to work on the pegn thing, the best thing to do if you want to get that is to rewrite a grammar in pegn and simulate how you would parse that and things like that. We're also going to need porting of things. So things are going to need to be ported at some point to other languages, and the reason I'm so getting this reference library done is if we do it right and really test it out and get our generators done, then it's just a matter of porting to other languages. So the single most important thing to do after I finish this re-ramp is the generators. We must finish the generator to make sure we didn't miss something. If we've made it a situation that cannot be generated somehow through our architecture, we got to make that known really quick, and we won't know that until we actually do some generation, and that's Quint's domain pain. So yeah. But it's going to get easier. All right. So yeah. All right. So our grammar, we have node names. We have I'm going to call them parsers. Yeah. I try a couple of other grammars for practice. Yeah. No, I mean like something simple. If you'd like to represent, if you want to get familiar with this, maybe read up an ABNF. ABNF and EBNF. Those are grammars you need to know to be a computer developer. So that won't hurt you to learn those. Pegn is just an extension of those kind of. You can go read the Peg paper if you want. So pegn.dev has a link to the paper from Brian Ford if you want to understand what's up with that. Yeah. Checks and classes. I almost don't even think I need these things anymore. But we'll see. Yeah, parsers by name. Map string parser. Put a check here. This is so much better. All right, this is the right thing to do. Grammar contains identifiers and pegn grammar. Community with the person. Don't need that anymore. This is just a collection. That's all it is at this point. So, actually, no, that needs to be an interface too. So, yeah, this is really good. I love this because it gives a representation of stuff. And yeah, node int name string. I don't care how that's implemented. Node names, node int parsers gives you this. Checks gives you that. I mean, you almost don't even need that. You could almost just say, okay, I want a given parser. But no, we want this because we want to be able to initialize a grammar to use the whole thing. That's also good because people can, like, if they're not going to print out the documentation, oh yeah, this is really going well then. So if they have the name, the description, and the pegn notation in the grammar, then people can recreate documentation and stuff like that from this grammar interface. So this is good. This is definitely good. All right, so that means that in the grammar, I need to have the grammar's going to implement this. Put this up here. Grammar component. Name, description, pegn. You have node parsers. You have checks. You have classes. You have tokens, which I don't have here currently. If I'm going to be like thorough, I need that though. Map string. It would be an interface. Tokens don't need identifiers. That would just be a map string interface, actually. I mean, the only reason I need this is so people can loop through it if they want to see all the tokens. And yeah. I'm actually starting to think that we need to have one. We need a token. Fuck. Rather than having it be, I don't know. Well, I'm going to make a room for it. I mean, if we're gonna fully document, if we wanted to reverse document the entire grammar from the interface itself, then we need this. There's some other things about the grammar that we're gonna need to do. So this is good. This is good. This is good. Yeah, I don't know. Token value, I guess. Well, no. I mean, the token can be an interface. It can be a rune or a string. I don't know. Let's say yeah. It's kind of implying the implementation of single runes as strings with one element. All right. Well, this is good. There are some other things about the grammar that I need to know. So we need to know, and these are actually the things that go in pegn. So these are all things I would have had to communicate anyway. This is really, really good. Okay, so I'm gonna go back and look at the spec for a second, because believe it or not, the pegn spec has the stuff I need to put in my interface here. So metadata, right? Meta, copyright, licensed, all that stuff needs to go in the grammar, in the computer programming version of the grammar representation. So if I have a grammar, I have all these things that I can go look at, names and stuff. So that would mean, so for example, do we have copyright licensed? It makes me want to put it in a meta, but yeah. License. I almost think that we need to be able to print the grammar in pegn. I might be going overboard, but I don't care. The language. Language. Lang extension. And what else? The version, major, minor, and patch and pre-version. That should probably be an integer. Yep, I'm going to do that. Major, minor. Free version. is a string. This is good. This feels right. And home. Home doesn't necessarily have to be a URL. It can be whatever. So I called it home instead. Prever. Where's my prever? There it is. Okay. Yeah, because these have to be digits, so we're good to go on that. The check IDs, the reserved IDs, all that stuff is going to pull up down here. The parsers, the checks, the classes, the tokens. Those are the main things. And yep, I think that's it. We can always add more things to the interface. We don't need our definitions. The definitions go with the other stuff, so that's why that's fine. So these things are all check functions. These things are all class functions. These things are all token functions. So every single thing that's in the grammar gets translated into something that can be fetched from the grammar interface, including the copyright. We don't have any of the comments in there, but we don't need that. So pegging down here is a rendering of all of this. We should probably have, let's just do this. I don't know, man. This is a tough one. Because I can actually have this pegn be generated from all this other stuff, or I can have it be the original pegn. The original pegn file. I think we need to put it in a constant. We need to put the entire specification in a constant that gets generated. Yep, I think we're going to do like a source. I don't know which one's which though. So this one, no, that could just be the verbatim original. Yeah. We don't need to pretty that up. That can be the original. This is just a constant. Yeah, that'll work. This is good to know because the generator is going to need, we need Quint so we can talk about generators. There's lots of work to do here before we get onto that point though. So yeah, that makes me feel very, very happy. Because I know what I'm building, frankly. And I mean, I knew before, but this is now starting to look more robust, put it that way. And frankly, portable. Because this can be implemented in Java or C++. Doesn't depend on any unique type switching from the Golang. I need to take a quick break, so watch some fish, and I will be back. There's your fish, JW Racing Team. See you soon. All right. Um. Oh, lots of work ahead, but it's fun work. Um. And the results are going to be spectacular. I can't wait because I've already seen it work. Um. So this is just going to make it that much easier. It'll make our code generation easier. So yeah. All right. And now we know how to render all that stuff in a nice happy way, sort of. I almost want to make the templates for each one of these things right now while we do this, so that I can be consistent as we create it. But I'm going to wait on that. All right. What's next? Well, that's all going to work. We need to rewrite this stuff in the parser to use the expect function, so we need to port that over eventually. I think the node library got directly ported. That doesn't need any adjustments. And rather than have an encapsulating entity over this stuff, yeah, the node knows about a grammar, and that's important because then the node can look up anything about the grammar that it wants to when it's doing error messages and stuff. And it's just a pointer. In fact, I don't even think it needs to be I think it needs to be a grammar because it's an interface. So anything that fulfills the grammar can do that. I'm trying to. The interfaces are interesting because it's anything. It could be a pointer. It could be anything that fulfills the grammar. Or I can make it say it's a pointer to something that fulfills the grammar. And this has to be a pointer because that's an actual node struct. And I can't put grammar there. I should probably test that right now. Invalid operator node names. Yep, there we go. I was afraid of that. So that's because grammar changed from being a struct. So string fulfills a string interface if n.grammar is not equal nil. I don't even know if I need that anymore. N.pretty. So this says don't pretty print it unless we have a grammar. Which makes me want to use a pointer. That's why I had a pointer in the first place. All right. And since it can be a pointer, it's not a problem. Yeah, that's fine. And then down here, we can do this. We can do grammar dot is it node names? I'm gonna have to make a lookup for this. What is the node name for i.type? I mean, it's not that much to add that on. N.type. This is just to look up. And this is just the pretty printer, so that's fine. There's no AST involved. I mean, the node name for an int. That's just a hash lookup. It's really redundant, but it may be that some people want to get all the node names and then just look them up. So if you just want to do one at a time, that's how you do that. That fulfills this. Yep. That should fulfill that. Interface, not an interface. No name undefined in grammar. What are you talking about? Huh. I don't know if I actually need a pointer to that. I don't think I do, because the interface is always weird. Yep, that fixed it. All right. So that definitely fixed it. Fixed it for sure. Oh, how's it going, visitors on YouTube? So yeah, this is all good. If I retrace my steps of how I built it in the first place, I built the node tree first, and then I built the parser, and then that kind of led to all the other stuff. So I should probably finish porting over the node stuff. However, I do think I'm at a place where I can make a commit. Or am I? Why is there... Oh my god, is there no... Oh, it's because they... Wait. I haven't added any of those yet. Fuck. Fukate. Yeah. Actually, if Greg's out there... Greg, are you out there? If Greg's out there, do you want to add your stuff to this if I commit it as a merge request? So... See this right here? I think we can get your merge request in after this one. I'm going to go ahead and save this. I think you can merge your stuff in. And then I'll get the other stuff going on, and if you want to merge in the calls to it, it'd be cool. So in the JSON here, I carved out a sub package for the JSON stuff. And I'm thinking you could put your stuff here. You know what I mean? So if we did JSON dot parse, what do you think? Something like this, function parse. You see what I'm saying? And then this is just a package. It's a sub package that we can call. It's got our version of JSON in it. I don't mind calling it JSON because if we do this, we're gonna boot JSON encoding out entirely. We're never gonna use it. I don't know. I mean, it doesn't matter. You put whatever you want. If it makes sense. Actually, let's do this. JSON.go to string.go. And you can just have a file in there, and then we won't have any merge conflicts if we do that. And then we can plug it in to this serialization thing later. In fact, if you want to do that too, let me just show you where that would go. And I'm not going to be touching that file, so if you're gonna do that, it would go in here. So this is right. And see what I did? I made it. I called it slow JSON. So any place that we're calling slow JSON should be calling your stuff. Is this here, right? However we want to do that. I don't know. Yeah, you get it. So yeah, and it doesn't have to be called unmarshal. It can be called whatever you want it to be. But this has to go in here. Let me go ahead and save this. Yeah, I need to do a git add dot get diff get status. So grammar file, the string file, the JSON mark. All right, so I'm going to go ahead. This is the main scaffolding for the objects and stuff. I'm trying to think if there's anything else we forgot. I don't think so. So I'm gonna commit this right now. I think it's just called parse. That's fine too. Whatever you want to call it. It doesn't matter. It just has to be called from. I prefer not to call it Marshall actually. So yeah, I like parse better, frankly. And we have JSON.string, which is cover. So yeah, I'm gonna go ahead and commit this, and you can do the merge request. And this is a clean, totally clean tree. So, yeah, and I gotta tell Ethan. Okay, anyway, it doesn't have to be right away. I just want it's totally free and clear for you to add it, and we'll just pop it back in. So yeah, I'll need to commit here. So what are we gonna call this? So we say domain model framework interfaces. Git push. Yay team. All right. So then I am. Oh, my back hurts. I'm going to finish testing and goldening the node model. That's why I mentioned it, because that's one of the few external dependencies I have in the node thing. And so yeah, okay, yeah, it's fine. No rush. Why do I have VI in here though? I cannot figure out how that happened. That must have been me being really dumb. Actually, get. It's right there. All right. That's so weird. All right. So I think we have all of the major files. Let's go look. Old libpagan. What do we have here? So grammar's come over. JSON's come over. Mark has come over. Node, and the parser. So we can now move over the node tester. Node tester has a bunch of stuff that depends on the parser. So I'll be moving that over. And just like really thoroughly testing node to get coverage on that. And then we'll do the parser. I want to figure out a way to test the grammar interfaces that is not. I really want to test those out so we have examples of how to write what the grammar generators are going to make, like every specific example. And I might even be able to pull a generator template into this reference. I'm kind of on the fence about whether I should have generator specific code in this thing, but I mean, it would make sense because you would be able to see how the grammar got generated. Plus, I could also probably save myself a lot of time. But that's more of a Quint might already have that. So when he pops on, we'll talk to him. All right, so yeah. Yeah, nothing here to test actually. I'm overly concerned about I'm gonna go. I don't know why. I just want to look at every file again. That's good. That's good. I just don't want shit to sneak in that's like not gonna get fixed later. And I always like put to dos on stuff, but so this has a bunch of documentation. I want to make sure that documentation is still accurate. Um, Mark remains a struct, and it always will be. That's not ever going to be an interface. I'm pretty sure that's where it lives. Pretty sure. Implements the Go stringer interface. I'm just trying to figure out where a stringer came from. There it is. Yep, FMT stringer. Good. All right. My printing user friendly I'm printing the mark location in a human friendly way. I promised myself I wasn't going to document anything yet, but I think that doing the testing and the documentation at the same time is probably good to go. All right, so yeah, let's do this. Let's do im. I need to get one of my examples. Fuck. Why are you not happy? All right. Oh, whoopsie. I got ah. Oh my god. All right. Like so lazy. Old libpegn node test. Let us see you. Nope, nope, nope to the nope. Parser test. Nope. I need to look through parser examples actually. I'm gonna find one. There we go. Mark.go. Okay, so let's see here. I can do some ASCII art here. ASCII art to the rescue. I'm not doing very good with my ASCII art. I need better ASCII art. I don't know how to do ASCII. All right, so that's the line. How do I do it like a turny thingy? It's so bad. And what is this guy? Let's call him the line offset. And this is the byte offset, right? Yeah. Oh, they can go over here. And this is do 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 do. And what is this guy? This guy is the God damn it. The overall rune offset. There. Pretty. I take a nap. It's only been 2 hours. I know, Z. The coffee just puts you to sleep at this point, right? Happy Monday, everybody. Actually, this guy comes over here. This guy goes over here. This guy gets one of these. I have a moment we can discuss the node int function quicksode. Hopefully I understand. Yeah. All it needs to do is return the integer. That's it. If you just want to do a linear search, that's fine for now. I'm just saying if you wanted to figure out how to search through that. It just needs to return the number that goes with the string. That's it. So if I do right, so if I give it an int, I want to get the string that goes with it. If I give it, and the other one is if I give it a name, I want the int. That's all. And that's it. I don't know. I just you know what? I'm kind of on the fence on that. I think that's fine. That's not how we would have done it without the search. But now that it's an interface, now that grammar's an interface, I'm totally okay with doing that. That just means it has to be auto-generated. So yeah, let's just do that. That makes the most sense. I kind of thought it'd be fun to do our own lookup. The problem is we don't need to internally store because the integers, are double as indexes. So yeah, because I have to have the numbers. Anyway. Yeah, I mean, we could just have a reverse index lookup. That's fine. I'm thinking about what it look. That's totally fine. I agree. I agree. Let's do that. Stop arguing about it. You're probably right. I mean, you're right. It is. It is. It is. It's going to be fastest. Now, I mean, you kind of think about it, because Go knows its hashing algorithm better than anybody else. So, you know, uh, and we would basically be rewriting that. So the only reason I was trying to get away from that, honestly, was to stop from the generation of that. So we're going to have to maintain kind of two of them. So yeah, I mean that's fine. It's totally fine. Let's just do that. Yeah, and then just getting the JSON stuff in there. That'll speed me along on the other stuff. I'm really tired. I need to take a nap. It's because I stayed up till like 2 last night. Alrighty. Um, yeah, we're gonna have the node in behind. We're gonna have we don't care how it's implemented. So because we have an interface, and that's already signing off on being slower anyway. If somebody wants to be like really fast, they can grab the node names themselves and get the whole string up early and cache it and do whatever they want. So that's not redundant because it does provide a different use case where somebody wants to cache all that data up front and they're really highly interested in high performance and they don't want to do the reverse lookup using map, but don't expose the map in the API. Yep. That's what this is. This is not going to expose the map, and then we'll use the map. Yeah, keep it simple. I agree. And now that we have an interface, it makes way more sense to do that. So, happy with that. All right. Yeah, we don't even care how it's implemented at that point. I was just really concerned with trading efficiency of looking that stuff up, but the fact of the matter is, if you're looking the name up, if you're looking you're telling me, yeah, if you're looking the int up, you're already dealing with the slower long form stuff anyway. So those use cases are all, it's still efficient, but it's that they're all, you've already signed off on. I'm trading performance here for simplicity. To make the map lazy, yeah. And then I really don't accidentally want to shoot our performance with the really concentrated AST with the integers in it, and so far we don't have anything that does, so I think we're good to go. Yeah, there's actually no dependencies on the grammar interface by either the node tree or the parser at all. I know, dude, but I had to. The whole reason for doing this was because the ASTs are really pieces of crap. You even told me how slow it was going to be. And the one that you looked at was actually based on sort of a recreation of the Haskell, pandoc long form ASTs, and that was all you got. And parsing was going to be a bitch and slow. And so one of the reasons I did this is like, no, we need a more highly performant parsable AST and its minimal form, and we need another long form for dealing with humans. And so when I went into it, I'm kind of hyper paranoid that I'm going to drop that efficiency somehow on accident by, sticking an interface where a structure would have been just fine. And as of this moment, both the parser and the node tree do not depend on the grammar interface at all. They can use it if it's given to them. If it's given to them, they can use it to give better error messages and stuff. But if they don't have it, they don't care. And they'll just stick with the ints and they'll trust the user on the other end. So we have the best of both worlds, and I'm really happy about that balance. And that just, yeah. It pays off to be lazy when it turns out you didn't need to do anything at all. Exactly. It's totally true. And that goes for documentation too, right? Fowler, is that a Martin? Mm-hmm. So, and so yeah, I'm totally on board with that. The Patterns Enterprise, yeah, that's the book. When'd you read that? I've been recommending that like crazy. Yeah, I was on my high horse there. I was like, hey, you need to read this before you read computing on data structures and algorithms. It's more important, and of course, it's not. I really like reading Kyle's book. It's Oh, right. Did you? Well, you know what? That just totally equates for me. Because Greg, you have no idea how many times I brought up that book and said nobody even knows this book exists. They go to computer science, they go to university, they graduate, and they have no idea patterns of business architecture is a thing. Because why? Because they've been learning nothing. Practicals is a swear word in computer science, departments, and that always bothered me because people come out and they have no idea how to make anything. And then they, and so it actually kind of made me a little bit triggered by the whole data structures and algorithms things. Yeah, yeah, data mapper. See, it's funny, Greg, because you just, out of necessity, you found the right things to use, right? And that I like combed over that book. I used the subscriber pattern so many times, and the queues and stuff. It's funny too because the enterprise patterns, a lot of them are based on computer science patterns. They're just at a macro level. Yeah, I'm finding that out now, and I'm also kind of softening. As I said, this book, Mastering Algorithms to C, is really softening my. It's Kyle. Kyle is like, calm down. I'm practical too. These are places where you really need to use the thing. We're not going to go into really ridiculously verbose theoretical proofs to tell you why you need to do this thing. We'll just tell you why it's more efficient, and you can actually use it. And I'm really glad because it is really kind of, I don't know, it calmed me down. So I can accept things like, linked lists and all this shit that obviously we need to use. Um, but yeah, he just made me, you know, be okay with it. Um, which is great. It's actually calmed me down so much. I actually am willing to maybe go through like a CS Masters just for fun because you can bust those out pretty quick. Does WGU even have a Masters? Let me go check. Uh, I know I'm kind of diverging. I'm trying to wake myself up. I'm pretty tired right now. My brain's not working very good. Um, IT. This is an accredited university. Uh, I have no affiliation with them. Cloud computing. That's a new one. I don't remember seeing that. That's probably got a bunch of AWS certs in it. Hmm. They're really, really big into certifications. Yep, there you go. Amazon AWS SysOp Administrator Associate. I have mixed feelings on that. The really great thing about WGU guys, and I have nothing to do with them. I'm working with a guy. When I first heard about it, I was really skeptical, and then one of the mothers of a person who's here brought it to my attention. They said, "Check this out." I'm like, I don't know, and then I'm kind of. It's a degree, at the end of the day. But the thing that's great about it is you can take as many credit hours as you want in that time. So you can cram all kinds of stuff in there. Seniors do linked lists from scratch. I go berserk. You just don't do that. There are so many conversations. Yeah. Unless you need to learn. Right, Mac. And that's what I'm trying to tell you about. So, see, what you have is practical knowledge of the existing libraries. And that makes people, pick them. You make mistakes. Yeah, of course you will. And I would actually rather make those mistakes as a learning activity than, yeah. And, reuse and optimization of exist. So like my rooted node tree that I'm making is probably exists someplace else, but it's very hard to find a generic AST implementation, a generic node tree implementation. BSD implementation Q-R. Oh, you don't like it? Interesting. Yeah, I'd love to see that. But yeah, that's new. So they have a cloud degree. Anyway, this is an organization that rewards you for being fast. So the more you can get done, the less money you pay. I think that's because they count on the fact that most people are not going to work fast. They're going to work 1 hour a day, and they're going to push it out for 7 years and pay them all kinds of money. There's a college that was actually formed to address the need for rural people in the West. That's why it's called Western Governors University, because they did not have access to universities. So it was one of the first correspondence universities in the nation. Software development, I would never get this. This is one of the bad ones. Information, no. IT, no. Data management, no. Analytics, no. Cybersecurity, maybe. Assurance, MS. I'm going to get that one at some point, just because. The BS in computer science, if I were to get the BS in computer science, it would be in addition to my existing bachelor's, which is probably one of the reasons I want to do this is because I could just like knock it out in a semester. I have a feeling. It's like people have done that. Mechanics have gone through this in one semester, from scratch, having no knowledge of how to code or anything. But a lot of it's reading and busy work. Why am I drawn to it? I don't know. Just because it's a piece of paper. Because, I'm an avid advocate of like practical learning, and but it's just so cheap. You can get an entire BS degree for $6,000 that's accredited. I've talked about it before, so I'm not going to talk about it anymore. Yeah. Also, it may or may not cover some of the gaps. Oh God. An online computer degree designed for you, from programming a robotic arm to learning Python. Oh, okay. I'm definitely look at all the certificates you get. You guys know how I feel about certificates, right? I had the guy that I've been helping. He got his web development foundations certificate. It doesn't even teach him JavaScript or the DOM. It's like such a joke. Data structures and algorithms 1 and 2, introduction to AI, scripting and programming applications, see all the courses, IT certifications. It comes with these IT certs that you have to take. There's like, yeah, ooh, Oracle. We're gonna get Oracle certified. Oh, it totally is, Mac. It's really shallow. The ITL certs are. It's like, yeah. You'd only get it because it's so cheap. It's so cheap. You can get a full bachelor's degree from an accredited institution, from the same accreditation agency that accredits BYU and Stanford and all the Western colleges, for $6,000. Maybe $12,000 if you took a year and a half, 2 years to do it. So if you are like looking for a piece of paper and kind of want to own the industry, like it's kind of a way to hack the system, right? Because if some HR person looks at you and says, "Oh, hey, look, they have a bachelor's in computer science." Not to mention they got 20 years, whatever experience. Udacity offers nano degrees. These are so stupid. These are so stupid. Um, they just are so. I actually have been helping a couple of people who went through the Udacity nano degrees and got their Python stuff. It's absolutely laughable. It's just totally laughable. And the ITIL Foundation, they're just crazy too. And then all of this CompTIA shit, right? So I don't know, man. I'm like looking at this going, this isn't even their pen testing one. Uh, wait. Interface designer. LPIC Linux essentials, people. I had guys at 15 get that. A master's of science is 5 years. Here it takes 3.5 years of hard work and engineering. I know. Ground down, no matter how clever you are. Of course, because it's probably real. Yeah. It's kind of a testament to how shitty American training and education is. It really is. I mean, people get out of there and they think they know shit, and they just don't. I don't know about that, man. I think Linux should be in a university course, but it should not be. I do think Linux should be in a university course, just not introduction. But that's better than there's universities here that force you to take a 3 credit hour Linux introduction class and pay the equivalent of $2,000 for it because you can't test out of it. It's just a fucking racket. The whole thing is a racket. It's all partnerships with all these people, including this company who lobbied to force people to get, to go through their program in order to even have the right to work on their electronic devices that they own. OS principles with Tenenbaum, and then you do project maybe taking this part. Yeah, completely agree with that approach. I completely agree with that approach. But then the dilemma remains. It's like people still have to face the music when it comes to getting a job, and I have lots of people who have gotten those jobs by just showing what they know, and they didn't have to, they demonstrated what they'd done on their own. You teach theory? I don't agree at all with that. I seriously and strongly disagree with that. The opposite. I think you need to learn these specific technologies that are relevant in the time and the place, as well as the theory. Yeah, I'm not a fan of. There are some things where obviously you have to use like theory, but it's more like learning algorithms, for example. That's theory, right? But it's so much more valuable when you have a practical application of that theory to work with as well. I just really, really believe that. An online degree at the same time. Information technology degrees, blah, blah, blah. Anyway, I don't know. I'm glad I looked at this real quick because I'm not as interested anymore. There's like so many better ways I could use that money. It's, not to mention, I don't know. So, not per credit. Subject to vendor availability. And if you already have any of these certs, they may transfer into your program as credit. You have to get Project Plus certified. You define yourself into, yeah. Yeah, I think you mentioned that. That's a good thing. Yeah, well, best engineers, I don't know. That's yet to be determined. But yeah. I mean, telling you, like, to the extent where you're pointing somebody in the right direction and then letting them go learn the practical stuff on their own. That I totally agree with. You don't, and so that's probably what I think you mean, is like, you don't show them the steps to do a thing in a college course. You like point them, you go over the steps and then point them and then say, hey, go do the steps. That's what I would do. It's challenge-based learning. Credentials and knowledge, you need to be a leader in your field. Not with CompTIA Project Plus. Oh, God. War in the world. According to the latest poll, if you say so, you sound like an American, my friend. You definitely have the confidence of an American. So data structures and algorithms. I need objective evidence for everything. It's never anything personal. That goes for my wife too. And that, you can never, it's tough. Flexibility schedule. Yeah, I don't know, man. I just, scripting and programming application software. So this is we downloaded the program guide. Actually, you know what? I already answered my own question because we do have somebody who's going through it, and I've been like kind of watching over his shoulder. He has to do this A+ cert. Oh God. Competency-based approach, accreditation. Wow, they've been accredited by lots. The problem with accreditation is, because I tried to get it actually, is it takes a year to get it. It's insane. Faculty, yes, they give you a mentor who can't even see your own materials. Confirmed. Continuous enrollment. Learning the resources. Standard path. I'm kind of off the path here, guys. I'll go back. I'm taking a little break. Standard path for Bachelor of Science. This is, I find, see, this is why I would not want to get a bachelor's. Because I have to do the stuff I've done already. This Web Foundations is an absolute joke. It's like a high school level HTML. Yeah, it's insanely bad. Introduction to IT. Probability and statistics, no. Geography. I'd have to actually take geography again. Probably a good idea. Yeah, me too. That's the thing. The discrete mathematics I'd probably like. I've been saying that because I've been kind of outlining my own program that includes lambda calculus and, Boolean algebra and stuff. Calculus 1. See, if I took this, it would be great because I was all the way, 300 level calc. English composition. See, this is the problem with getting a bachelor's from a place like this. You have to do this shit that you don't necessarily, I could probably teach half of these classes, and I don't mean that to sound arrogant. It's just like scripting and programming foundations. Integrated physical sciences. The natural science lab. Because it's a bachelor's, right? So it has to be, quote, well-rounded. Computer architecture. Here's where the CPU is, people. Data management. American politics. That's a required class. Oh, I know. It's Java. I know, dude. I know. Advanced Java. And actually, they use Java to teach. If that's one of the reasons I'm looking through it. Project management. The business of IT. Their data instructions and algorithms is probably weak anyway. So if I go through 3 books that cover it at the MIT level, I would be more satisfied. Yeah, I know, Mac. You and I agree on the all caps on that one, my friend. Ethics and technology. Fundamentals of information security. I gotta keep telling myself, this is, if you're 18 and you're just coming out of high school, just to be teaching less, you know what? I kind of wish they would too. They do Python now. Yeah, you're talking about MIT? MIT switched. Yep, they did. Full semester on Java. Yep. Yeah, they did. I kind of wish they hadn't. I would have gone back. MIT has open curriculum too, so you can actually go through all the MIT stuff. You just don't get the lectures and thing. I did that for guitar. Actually, it's one of the ways I learned guitar. I went through MIT's guitar-ish course. They have a great music program actually. It's crazy. I had a guy that I met at an open mic, picked up my guitar and just went nut to town. I was like, dude, where did you learn? And he's like, MIT. I'm like, what? Yeah, he went to the MIT music department. I never would have guessed. Um, Technical communication, intro to AI, quality assurance. That's it? You've got to be fucking kidding me. That is it? That's a bachelor's? Sex on horses. Um, you've got to be kidding me. You've got to be kidding me. I mean, yeah. This is I don't know. I think it's 3 terms, trimesters. Still, that is like so weak. There's no software development in here at all. There's no applications development in this entire. There's software engineering. There's one class of software engineering. One. There's one class of software engineering. That is. Oh my god. No, they don't. There's this guy, this mechanic who went through the whole program on YouTube. I watched all his videos, and they're because I was trying to decide. Oh, it's only courses. This is nonsense. Yeah, and they don't expect you to do anything on the side either. They expect you to go take the certifications. Yeah. So the thing okay, I still am not against the W2 in America. In America, there's places that will not hire you unless you have a degree. And the Adam Ruins Everything did a thing on college and said that the stats still are that people who have a college degree are paid 30% more at every level of their career, whether or not it's justified. So this is like if you want to hack the system and get a piece of paper, because you can't get the job without the piece of paper, you know. And corporations and companies, yeah, Mac, that's definitely the way to do it. That's it's funny because when we do that with medical stuff, right? It's almost like America has figured out how to help people actually learn when people are going to die. So the medical profession is pretty good. And my friend, he's a surgeon. The medical profession is pretty damn good at making sure you actually learn what you're doing and having lots of literally hands-on experience. But it takes like 9, 10, 12 years to get through the program because there's so much internship and stuff that's mandated. Stuff like this, it's like, hey, here's your paper, go work. It's just nuts. It just makes me crazy. I really don't like it. Get the stitches in my thumb. Went to WCU. WCU medical program. Companies basically buy up the universities. Yeah. Before medical, it was U.S. military. Yes. Raytheon. Oh God. Yeah. Yep. Yeah. Raytheon. Actually, Raytheon bought the IT department at Nike when I was there. Mm-hmm. I tell you, let me just, if you're ever into business management, don't put a bunch of people who work at Nike by choice in a room and show them missiles and shit blowing up to make you excited about changing to their company because you just got bought out. They just, quote unquote, outsourced all of your IT to this military company after having worked at Nike and being, totally drinking the Kool-Aid on all the Nike ads. Like everybody in the room, people were like walking out. It's like, at Raytheon, you'll be a part of missiles like launching and shit, compared to like the Nike ads with like I, I was it was so funny. It was like, you just don't have a fucking clue. I can't remember if it was Raytheon or if it was, oh God, what's the other one? The two big, military ones, over here. There's like couple of big ones. Obviously I need another break. I'm taking way too many breaks today. I'm not being efficient. Northrop, yes. Yes. Northrop Grumman. I think that was it. That was the one. Yeah, and I was down in I was down in Arizona, and they were in the same building with us at IBM too. Yeah, it's pretty intense, man. They had their like engine, like the engine lab is down there. Occasionally you'd see some of the equipment coming in and going out. It was like serious equipment, man. Super cool stuff. Lockheed is the one. Lockheed is the. Thank you, thank you, thank you, thank you, thank you. That was it. It was not Northrop. I keep mixing them all up. There's Raytheon, Northrop, and Lockheed. Talk about money, man. The amount of money that those companies have. Weapons manufacturer because fun testing. Yeah. There you go. Well, there's a bunch of that kind of stuff in that space, I think, right? Weaponized embedded devices. Yep. Yep, 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 yep. It's not as fun as making a language parser. So, what am I got to work on? Oh, I was like messing with my mark. I made this nice, pretty documentation thingy. So yeah, I should probably make a smiley. Do I dare? I'm gonna do a smiley. I'm gonna do a smiley. Smiley. How big is the smiley? All right. I don't know which one this is, so fuck. Actually, no. Give me a second. Give me a second. Where's some fun stuff? Where is some fun stuff? There we go. Wait. I don't have the output from that one. Otherwise, I would do that one instead. I'm just cheating. I'm trying to find a good example here of some scanning. Yep, there we go. That's what I want. Hi, you. There we go. There's a good one right there. Much more fun. Do 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 do. I mean, let's pretend like it saw something. So it'd be like an extra 3. Anyway, I have people walking. It might be time for me to go for a walk. I think that's what I need. I need a walk. Which means I'm gonna drop and I'll come back. So yeah. When I come back, I'm gonna regroup and I'll be writing the grammar up. I'll be finished testing out the Node library, and I want to get this whole thing done today, but I don't know if I'm gonna be able to do it. The grammar implementation might have to wait, but the rest of the testing of it can probably happen today. Hey, oh, she's doing her thing from yoga. So I have a little bit of time. I definitely need to stand up though. My eyes are gonna fall asleep. Give me a sec. Hey Doris. Doris. Are we going walking after this? Are we going walking after that? Let me shower, eat, then we can walk. Okay. Yoga pants. Yoga pants. Well, there's plenty of opportunity for that around. Oh, I had to put a jacket on. I'm getting cold. Fall is setting in. It makes me want to hibernate. Anyone else having that problem? I do too. Me too. I really love it. But yeah, but I tell you what, it puts me to sleep, man. I'm convinced there's something genetic about hibernation. As soon as this type of weather hits, it's so hard for me to stay awake. Yeah, so that's the way it is right here. We're gonna go for a walk here. All right. A little shout out to our YouTubers if we have any. Hey, we do. Hello, YouTubers. Can't talk to you, unfortunately, as well as I would like. But I will fix that eventually. I have to reward myself with that fun kind of coding after I finish this. Just there for the fish. And what would be wrong with that? I'm going to copy over the node test one at a time. So I think the node thing is all the way tested. I just need to copy over. Nope. Let's do this. Let's copy. Copy node test to here. And this is going to change, of course. Change this guy here. Actually, if we do this, we can go pegn-go. Turn on some testing. All right. Pegn.new node. Get rid of that. What? Pegn_test. Yeah. Yes, sir. It is. We went through a bunch of review. The gRPC project and some of the other ones. It's definitely the standard. Like it or not, hate it. It's the standard. There's not one that starts with lib. It's too confusing. So, what happened to my node line? Did I get rid of the constructor? I think I did. I think I did. I always wonder about that, if I should have a constructor. You know what? No. Because this is very public and it's related to... Okay, so... Yeah, I made a conscious decision to remove the constructor there. Because it seems like it doesn't make sense if you make all your public structure. Then it's like, why would you do that? So that could be confusing about which one's best to use. So, I'm glad I found that. We'll go ahead and change these examples that use this. And so, yeah. Anytime we have this, well, this is why I had it, actually. I wanted to be able to pass. That's like totally busted now. We don't have types anymore. This is a completely irrelevant test now. New node types. can't pass in the types. You have to pass in a full grammar. And you can't have a grammar unless it fulfills everything. This makes me wonder if I should break up the grammar interface. It'd be easier to test if I did that. What am I thinking here? I'm thinking about, so if I'm going to write a test for this, and the way to do that now would be to make a grammar implementation here so they could see how to implement a grammar and then pass that. But the reason it's a good idea to keep your interfaces small is so that you don't have to have things implementing everything. I couldn't even make a grammar in there to test that without having all of this. And that kind of makes me want to break this down. This interface there's no cost to this abstraction at all. And it would simplify the interface for the grammar. It would look really weird though, to people who aren't familiar with it. So if I were to do this, type has tokens, interface, and then tokens. So we put this here, right? And so yeah, we could say, up here we could say has tokens. Don't even have to do anything else. That's enough. What's up? Top level distinction. Oh. All right. So has tokens. If we do that, then I can implement just that one thing to test it. I don't have to implement everything. And I know it looks like it's a lot of extra work to do that, but that is kind of consistent with the small interfaces laws. And I mean, it defeats the whole purpose of using interfaces without something like that. So I don't know. I'm gonna just play with this. It's not gonna hurt anything. It will actually make my test cases a lot easier. So and yeah. So we could say, language, a language interface. I mean, I could even do that. I could even say that the metadata. Yeah, I mean, this is where you can really get into, and I'm not opposed to it. I just and so the meta has a language version, home, copyright, and license. Language version, home, copyright, and license. So home is a string. It has a home. It has a home. None of this stuff you can set. This is expecting it to be called from the grammar. And then so you could say I have a meta tokens. I think I can get away with tokens and classes. Yep. Tokens, classes. So meta includes language. Yeah, this doesn't look like it makes any sense when you're just starting out, but it stops you from stuff later. Let's start with go, yeah. And so yeah, that's in meta. We need version next. Part of the version interface. This is the right thing to do. And the cool thing is I can actually use this for other stuff if I wanted to, but don't know that I need to. Version copyright classes version. Actually, that's on meta. Home is its own thing. I think we already put that in there. Or did we? Home, yep. Home can go away. Copyright and license can go away. Call that legal, I guess. Type legal. And change this to legal. Language, version, legal, home. Let's see. We have the nodes. Type nodes interface. And we can put all of this in there. So we have nodes, classes, parsers, and checks. All right. And we have the raw pagan string returns the original. I can put that up here. It doesn't matter. So yeah, there we go. And now we have a grammar. Grammar has meta, tokens, nodes, classes, parsers. I mean, you can even do this. Again, none of this is hurting us efficiency-wise. It's just a way to clarify how stuff's categorized. It's actually one of the better things about interfaces. I really like it. So we have the original meta string, and then we have the components and the meta. We have meta, components, and a pegn. And any of those things can be broken down. This also gives me an opportunity to document each of these things at the interface level. That can give people information about how to implement them through code generation or otherwise. Interface. All right, back to where we were before. I think I'm going to just add that one. Added, let's see, broke out grammar into smaller composable interfaces. So that's the thing. That's good. I'm glad we did that. All right, now we have to fix our our test. So see, the thing of this is before the types were being passed, and now I need to pass something that fulfills the grammar, but I don't want to have to fulfill the entire grammar right here in this little example. It'd be impossible. It'd take forever. I have to write the whole thing. Has no tests right now. No. Nope. I'm writing them. Greg. I'm just kind of slowly going in there. If you want to include a test case with your JSON stuff, that'd be cool. Yeah, I haven't moved any of that over yet. That's what I'm doing right now. I'm like, I got the scaffolding and the framework done, and now I have to test each piece, and I'll be slowly, incrementally putting those in. I'm trying. I don't remember if you can check test code coverage on a specific regular expression match like they do with tests in general. If so, then I'm going to get full code coverage for every like main file. So yeah. Yeah. I have to rewrite this in a way that is going to work. And so sum is going to be a new node. But then I need to do something to it. So we need to set its grammar. I'm trying to think of we could do that. I think fuck. I mean, that factoring out was good, but I don't think it bought as much as I thought because it's not going to. Yeah, it's not. Fuck, because it's defined to be a grammar. That means it has to fulfill the entire interface. Otherwise, I have to change what the node is defined to be. And to tell you the truth, I don't know that I even need all of the grammar definition in a node. Huh. I'm trying to think if I can like look at the interfaces and get down with less. All I need is the nodes interface. I don't need any of the other interfaces. This is nice because that's why, decomposing the. Yep, that's it. All I need is the nodes interface. That is wondrous. That is glorious. That actually changed my design. Yeah. In fact, I don't even need. Yeah, I do need that. Never mind. So I just need something that implements the nodes interface. And so then on like 289, if does not equal nil, then pretty print it. Wow. That is when doing the right thing ends up helping you without wanting to be helped. That's really awesome. All right, so god damn, that's beautiful. So happy about that. Yeah, look at how nice this just got. Nodes. Node name. on line 33. What? Yeah, this is some good shit. Good shit. Yeah, that is really really awesome. So I need to make a new pegn node, and do another one here. It's gonna fail because it's gonna say we don't have, yeah, types not declared. So that's fine. We just need to declare a struct that fulfills the interface for nodes, and I mean, I really don't even need that. I could just use, yeah. Yeah, I already took all that out of the other one. See this? So types will cover not used. Let's get rid of them. Something. I almost need to make a test here that has fulfills. It sees its own test. That's what I need. This I'll just do this for now. This is fine. Yep. All right. So we do need to make a test that has its own node implementation. So yeah, let's add that to the end here. So type example node, and we're gonna do an example of node with node. Wait, there is no method. So let's see. It would be nodes. Output blah. Expected blah, found blah. Oops. All right. So first of all, we have to make one. Fulfill the pegn nodes interface. So we have to make a thing that does that. I don't know if it's going to let me do this. We'll see. Nodes. We'll say no. Let's say this. Type nodes struct. I don't think it's going to let me do this actually. We're going to see. And I mean, it doesn't have to be that big a deal. So, and then we have nodes dot. Fuck. Wait, grammar. I need to probably pull this in. All right. Paste that in here. Nodes. Oopsie. I don't think I can do this. In fact, I'm positive I can't do this. But I'm going to try it anyway. Watch so that you guys see this beautiful error. So I'm going to put a receiver here and try to declare the nodes at the node names interface. and it will not work, I promise. It should not work. It should not work. 527. Yep. See? It's like expecting up round found this thing. Because this is you can't do this, I don't think. I do wait, return no. Nope, 527, column 31. There you go. Can't have it. I mostly think that's because you can't have a struct declaration inside of an example. I'm a little curious how to do that. I think I would have to use the other example syntax, which does not associate directly with anything, because I have to show that in a file. It has to show where that's getting defined. Because that's not a thing. It's that you can never use function declarations inside of a block. So if I pull this code out and I put it here, it should work. Yep, see that? But you can't have receiver functions methods inside of a block, because it doesn't belong there. And Python will happily let you do that, but Go does not like it. Go doesn't like that, and that's for good reason. I mean, it's not clear. But of course, as soon as I do that, now I've blown away my example. So my example can't be present, which means I have to use another syntax for the example if I want to have this in the documentation at all. And that triggers me to look for Golang example tests. And there's a convention for doing this. Using example testing. None of that is any good. I don't want any of that. Nope. Worked example. Nope, 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 nope. That's like such a shitty blog post. Testing, benchmarks, examples. Here we go. The package also runs and verifies example code. Example functions may include a concluding line comment that begins with output or unordered output. I wish they would have put that there. It's not covered anywhere else. And you know what? I need to apply. You know what? I need to do a git push to the Go language itself on that, because that really needs to be clarified. It's so important. It's totally missed. And it's compared with the standard output of the function when the tests are run. I wonder if I could actually get a commit on that. I need to put that in my to-do. I can't import. No, Peg is not going to import any JSON but yours. So do you have a cyclical import? What are you using in there? So let me go look at that. Let me just save that for a second. All right. So you're saying the JSON parser needs the pegn-go return type. What's this in the JSON package came for? Here's the JSON. Yeah, you have circular import shit going on. Yep. I mean, I don't care if you put it. I thought that might be better to do it that way, but maybe we should just move it up out of there. I think that might be the easiest fix. You know what I'm saying? Yeah, yeah. It's just faster. Who gives a shit, right? I mean, I thought it would be nice and clean that way, but yeah, let's do that. So if you want to, if you want to do that in this commit, just move everything out of the JSON package and subpackage, and then bring it up to the top again in a single file or two files. Who cares? And then that'll get rid of your cyclical shit. Yeah. All right. Let's do that. And so yeah, I'm reading about examples. Wait, where'd it go? Where did it go? Oh God. What is up with that? What is up with that? This whole thing needs to be killed. Oh fuck, please don't save. You ever do that? You leave like old stuff around and then you're like, oh shit. I still haven't. Yeah, I still have more here. This guy's still there. I don't know what I've been told. Oh God. I think I was zoomed in or something. Oh God. Do. Still have something over here. What's up with that? There we go. CD into pegn/pegn-go. And there we are. Okay, so node. I have that problem with node. So I was currently looking up how to demonstrate this in an example thing. I'm pretty sure I can have something _test on this that has that as a just a straight up example. I don't know how many of those you can have per package though, so that's what I'm researching. So Golang, I'm pretty sure. Oh boy. Oh boy. Oh boy. Examples. All right, so here we go. We have our example. Hello, blah, blah, blah. Example perm, and it runs it. Example functions without output comments are compiled but not executed. The naming convention to declare examples for the package is function f, type t, and method m, or type t are blah. Multiple example functions can have a suffix, which I've used a lot. The entire test file is presented as the example when it contains a single example function. The entire test file. So that means that implies we can have more than one test file. That's what I was asking. When it contains a single example function, at least one other function type, variable, constant declaration, or type, which is benchmark functions. Perfect. That's exactly what I want, because that means I can rip out this stuff and I can put it into a what do we call it? Let's call it like node grammar example node grammar. Go there. And so this entire file will be used. There's another way to do this too, though. Part of the problem is that, let's see, the entire test file, when it contains a single example function, at least one other function type, variable, or constant declaration, and no test or benchmark functions. Our test file is presented an example when it contains a single example function, at least one other function type or variable, and constant declarations. Okay, that's what I'm talking about. So if you have this, so we'll do pegn test, and we're going to need our example function. So we'll say here example. And it doesn't necessarily have to evaluate. In fact, it shouldn't. And then up here, we can have our struct that we defined. So we can do all of our implementation. So we can do node names, func and nodes, node name string, and then func, whoops. Then node int. I mean, this is going to be really fast. Okay, so fills the pegn.nodes interface. And then we can have our example down here. I mean, I think we could have the output, I guess. I don't know. Let's just test it. Blah. Wow. It just evaluates it. I don't think it actually does anything. It doesn't. It definitely doesn't. It just makes sure it compiles. So yeah. And so, yeah, we can actually give it an example of what we want. So the node names, we could actually do this. We could say names. Well, no, let's do this. I don't know. Let's. New nodes. And what? Node names. I mean, I could. I mean, it doesn't matter. NDS names equals a string and then what? Then we can do this goes here, so this just returns, it's just an accessor. Return names. This is pretty idiomatic, actually, as fulfilling interfaces, like really in this very small way. Node type int string. So that's a pretty easy one. Return names int. And then this one can fulfill it as node int. That's a little bit harder, right? So I mean, let's do this slow one. For n comma for equals 0 and no n comma v range and dot names. If v equals name, return in. Linear, kind of lame linear search, but oh well. So then what? Then we can do this. We can say yay, Greg, thank you very much. Approve. I should probably read it. Yay. Parser.go. Same thing as before we reread, right? Yeah, I recognize it from our last peer review thing. Yeah, it looks good. It's so cool. I'm so proud that that's getting contributed. I'm glad you're getting credit for this. This is super cool. Our own personal super fast parser. Ooh, test case. Nice. And change it out and use the new one. I'm curious, did this oh, that's in the test. No, it's not. Huh. I'm wondering. Oh, you got rid of it. Okay, it's got rid of it. Never mind. All right. Yeah. Okay, I see now. Yep. Hey, why don't you fuck right off, said Timothy. All right, so Marshall JSON. Hey, everybody make sure to go like banish bigfollowers.com Never ever do anything with them because they're dumb shit, evil spammers. You do some person it. Oh, great. Great. That's all it took? Ha! It's wonderful. Very happy. Yeah, string. Oh, ooh. That's kind of scary, actually. I'm gonna accept this, but I think we probably should call that JSON string instead. Yeah, let's definitely. It was once JSON string, and when I moved it into its, you want to do that? All right, let's do that. Lest people get confused. Yeah, otherwise it looks good. Looks really good. Yeah, that's what it was before I got crazy and put it in a sub package. All right. Yeah. I probably should just do this. I should probably say I mean, you shouldn't be able to set it. This is the idea of this is it's going to be auto generated. So that's why I'm trying to do this. Another node. Actually, we can make this a constant. If you know what I'm saying. Yep. Uh-huh. Yes. We also need a constant with, let's see. Map string int. And so yeah. Actually, let's do this. Some node. And put this there. I don't want people to make a mistake here. I'm just trying to simulate what's going to happen. Return names int, or return. Actually, as you said, return node ints name. Oops. Node names int node ints names. Change this to names. Names and ints. There you go. Oh, puts a line there. Fine. That's not too bad. This goes away. And we can go ahead and, oh, did you update it? Refresh. I wonder if that'll work. Changes. Yep, that works. That works for sure. Commits. Merge request 1. Oopsie. Approve. Might as well. Do. I want to merge it. This should merge it, right? No. Green button, no. Yes, I know. It's like, here we go. Merge comment. There it is. Squash convince to convince will merge. You want to squash them or no? Are they just one-liners? No merging. Okay, let's just go ahead and merge. Hi. Go for a walk?
Yes, now.
Now?
Because Otto just remembered the whole gastronomy is not a word thing.
So you want to stop that?
And so I want you to leave the house quickly before
he's going to come. He's going to tell me that gastronomy is not a word. I never said gastronomy was not a word.
It doesn't matter what
I've never ever said that. All right, guys, I have to go. Let me go merge this. Thank you, Gary. Greg. I have a friend named Gary. Very, very awesome. Let me go ahead and pull this down. Git pull. Local changes to file by merge to node.go. I will reserve. Oh, let's deal with that later. I'll be back. I'm going to cut this